This is a video on finding the velocity using the derivative. The question states, a rock is thrown upward with an initial velocity of 8 feet per second from the top of a 200-foot cliff. What will the rock's velocity be when it hits bottom? So what we have here is a position and velocity question. And when we have such a question, we use a big formula that says the position, which I'll call S of t, is equal to negative 16 t squared plus v naught t plus s naught, where v naught is the initial velocity and s naught is the initial position. Here I'm using negative 16 because our units are in feet. Had it been in meters and seconds, we would use a negative 4.9. So next, let's look at the problem again and notice that the initial velocity is 8 feet per second. So that means v naught is 8. And the initial position is 200 feet because it's on top of the 200-foot cliff. So that's what s naught is. I can plug those numbers in, and I have my position function for our particular rock. So now we want the rock's velocity when it hits bottom. So let's first figure out what the time is when it hits bottom. Well, when the rock hits the bottom by definition is at 0 feet above the ground. So what we can do is set S of t equal to 0. And we get 0 equals negative 16t squared plus 8t plus 200. And this is just a quadratic. Notice I haven't done any calculus yet. This is just algebra. So I solve it using the quadratic formula or a calculator. And I got that t was about equal to negative 3.3, or t is about equal to 3.8. T is time in seconds from when we threw the rock. Negative time, the rock's still in our hand, so that's not the answer. It's not going to be on the bottom of the cliff. So our time at which it hits the bottom is 3.8 seconds. Now that's not the question. We want the velocity when it hits the bottom. So the relationship between position and velocity is that the velocity is the derivative of the position function. So I next take the derivative of our position function. So if our position function is negative 16t squared plus 8t plus 200, I take the derivative. The derivative of t squared is 2t. 2 times 16 is 32. So I get negative 32t. The derivative of 8t is just 8. And the derivative of 200 is 0. It goes away. So there's my velocity function. So my final step is to plug in my time when it hits the bottom, which is 3.8. And I get that s prime of t, or the velocity at 3.8, is equal to negative 32 times 3.8 plus 8. And put that in the calculator. And I got negative 113.6. Notice we expected a negative. And that's something you all know about gravity, is that if a rock goes down a cliff, it goes down, not up. And downwards is negative. So we can conclude that the rock's velocity will be negative 113.6 feet per second when it hits the bottom. And I'm done with the problem.